Hi there, I'm David.
Hi there, I'm Ronit.
Hi there, I'm Nina.
And this is our ECE Capstone project, Search and Shine. Search and Shine is centered around our rover, designed to autonomously locate people, and upon finding them, aims a laser and shines it directly at them. This is used to help rescue workers by providing an extra eye to help search with, or allowing search in non-human safe conditions. Our project is centered around three components: the rover, the computer vision servers, and our web app. Let's look into our rover first. The rover consists of 5 main components: the rover body itself, the Raspberry Pi, the camera, the laser, and the PTZ controller, or the pan-tilt zoom controller. We'll be going over each of these in more depth. The rover is a 4-wheel drive wave-share wave rover. It provides the main body for our project and is the main component that allows the movement through all of the searching and rescuing. The Raspberry Pi aboard the rover provides the brains and the controls of the rover. It controls the rover through UART communication by sending JSON commands as predefined within the rover's specifications. It is also capable of controlling the pan-tilt zoom controller through I2C commands. Lastly, it obtains the camera data through a ribbon cable on the top. Essentially, the Raspberry Pi is the main computer that gathers all of the information required throughout the rover and processes it all before sending it out. Next up is the camera. The camera is an IMX219 camera, and as per the name of the rover, Search and Shine, the camera is what enables us to do the searching. The camera obtains photo data, and it then feeds this video feed to the Raspberry Pi. The Raspberry Pi, which is connected to Wi-Fi, can then send this out to the other 2 portions which we need. This includes our image processing, which we use to view elsewhere, along with the web app. Next, we have the laser head. The laser head is mounted right next to the camera and is controlled by a simple MOSFET switch circuit. This allows the Raspberry Pi to control when the laser turns on, which is when the target is found and is in position. When the rover is performing its search and detects the person, it will then try to centralize the person and then shine the laser at the person, right in the middle. Finally, we have the pan-tilt zoom controller. The pan-tilt zoom controller is primarily used to pan and tilt, in our case, not zoom. Essentially, what the panning and tilting allows us to do is that it allows us to achieve the targeting abilities of the rover. The rover first uses the camera to position the target, and then turns the laser on when the target is centralized. Doing so essentially means that the pan-tilt zoom controller handles both searching and shining, knocking out 2 birds with 1 stone. Overall, everything is powered by the rover, making it completely autonomous and free to roam. The 5 components work together to manage to have our rover accomplish both searching and shining. Now that I've talked about the general hardware of our project, my colleague Ronit will now discuss the other 2 portions, the computer vision servers and the web app.
The computer vision server and the web app are absolutely critical to our project. The computer vision servers allow the rover to see, and the web app allows us to see what the rover sees. Let's take a look into how each of these subsystems work.
The web application displays the live camera feed and the location of our rover. Doing so allows rescuers to see what the rover sees and where it is as it searches. We also provide security of the website. This is done through login and registration functionality, as well with the use of cross-request forgery tokens. Moving on from the web app, our Search and Shine rover needs to be able to search, and accomplishes that through computer vision, which is my personal favorite feature of our project. Computer vision is essentially a way to derive information from an image or video using artificial intelligence. We use an algorithm called YOLO, which stands for You Only Look Once, to detect whether a person is in a video frame received from the camera David talked about. Video frames are received on the computer vision server from the Rover camera using Wi-Fi. After running computer vision on these video frames, the server also calculates how much the camera mount should turn to point the laser exactly at the unit. This information is then sent back to the Raspberry Pi, and the Raspberry Pi instructs the camera mount to turn. So that was the general overview of how communication in our system works. However, this communication takes time. Rescue workers need information, and they need information fast. Even though humans could basically process what they see immediately, computers cannot. Hence, we must harness the power of multiple computers to ensure computer vision occurs fast. This can be achieved through a distributed system, which is a system consisting of multiple computers to speed up computer vision. Using such a system is ideal because we have many video frames to process. Processing each video frame one at a time is very inefficient, so using multiple computers to do this is ideal. For our Search and Shine rover, we decided to use 4 server nodes to process image. As you can see from the graph, using fewer than 4 nodes does not give us enough speedup as less computers are used. Additionally, using more than 4 nodes gives us a lower speedup due to the high cost of communication between server nodes. Hence, for our system to work, 4 nodes is optimal.
It certainly wasn't easy putting all of this together. Our colleague Nina has some amazing stories about our challenges along the way.
All along the way, we had many different challenges. We tried 5 different Raspberry Pis due to having hardware issues, such as inability to connect to Wi-Fi, having a broken TX pin, and even burning through our SD cards. The libraries and the camera that we were using was severely deprecated as well, so that involved us having to update our Raspberry Pi OS, change our config files, and also install new dependencies. Working out communication between our components was difficult as well, as we needed to consider data transfer and input-outputs between our rover, our master CV server, and our web app. And just when everything started to work out, 2 days before our final demo, our rover fell off the table. And did I forget to mention, our project didn't even used to be using a rover. We had a drone in mind instead. Anyways, enough talk about our troubles. Let's see our rover in action.
There's nothing more exciting than a live demo. Watch as our little rover come and finds me. Thank you for watching. We really do appreciate you taking the time to learn about our project.
If you're interested in learning more about our project, you can always check out our website, and you can scan the QR code that's about to pop up now to go to our website.
Anyways, that's about it from us. Thank you again, and we hope you enjoyed
Search and Shine.